Now, log laws are very, very particular. They are laws, and you are not allowed to break them, and you are not allowed to make up new laws just because you want the answer to work in your favor. So, by particular, I mean very, very particular. Right? If the bases aren't the same, you can't use the log law. And number one mistake that happens here in A is a student sees, oh, log plus log. I'll use the first log law that we have listed here, because it's log plus log. But here, do you see that it's log plus, and then there's a 3 in front? But in the log law, it's just 1 log plus 1 log. So you are not allowed to use this first log law because there's that 3 in front. So you're going to find out that when you want to write things as a single logarithm, this is another way of them asking you to simplify. Because everything on the left-hand side is a single logarithm, everything on the right-hand side is not a single logarithm. You're going to find that you use this one first a lot. Because the first log law with the adding and the last log law with the subtracting, they only work when it's 1 log plus 1 log and 1 log minus 1 log. So we have a little bit of a problem. But if I take A and first say, well, if there's a number in front, I can just move that in as an exponent. That's log law number 2. And now I have 1 log plus 1 log. The bases are the same, so I can combine these by multiplying and get log xy cubed. Same thing in B. The 2 out in front and the 4 out in front cause problems for the first log law and the third log law. So as a starting point, the first thing I'm going to do is I'm going to put that 2 in as an exponent. And I'm going to put that 4 in as an exponent. So I have log y squared and I have a log z to the 4. Now I'm going to do an in-between step that you don't have to do. In fact, I want you to not do it. And I'll show you what I mean in a second. So here I have a log plus a log. Would you agree that you could put those together to be log y squared and you would still have the minus log z to the 4th? And then if you're subtracting, you would get this. Now it is perfectly acceptable to go from here to here with a little shortcut. And the little shortcut is quite easy. Whatever you're adding, that will always get combined to be multiplying and it will come up in your numerator. Whatever you're subtracting has to be divided in the end. So even if you're subtracting more than one thing, all of those subtracting ones are going to show up together in your denominator. So just to really show this, I'm going to add an example in between B and C. We'll call it B.5. If you had, and I'll already put the exponents in, so we'll say log A squared plus log B minus log C cubed minus log D squared plus log F to the 4 minus log, oh, I'm running, I'll have to stop. If I had all of that, and they said combine it as a single logarithm, you could take your time and do 1 log law at a time. I'm going to tell you that sometimes that causes errors, but the shortcut is really, really nice. How many are added? The A squared, the B, and the F to the 4th. So we're going to get an A squared, we're going to get a B, and we're going to get an F to the 4th in our numerator. How many are subtracted? the c cubed, the d squared, and the h to the 4. So I'm going to have a c cubed, a d squared, and an h to the 4 in my denominator. And that's way better than just putting 2 together at a time and having to write over and over and over again. And then they've got part C. Oh my goodness. They have a subtract sign. I'm going to scroll up and look at my log laws again. None of my log laws have a number all by themselves. This is problematic. In fact, I'm going to make a note. I do not like that 3. Right? It would be, I can only use a log law. Like with subtracting, the only log law, if you're not allowed to do any kind of, it would need to have the same base. It'd have to look like this. And then all of a sudden you're like, hey, wait a minute, I want it to equal 3. Can you see that I could put an 8 in there? And log 2 of 8, that's equal to 3. And I'm like, yeah, that's way better. And now it fits my log law, so I could take this, log 2 of 6 minus log 2 of 8 will be log 2 of 6 divided by 8, which if I wanted to reduce that, I could. Which, if I really wanted to, like, if this was just getting you ready for AP Calculus next year, they like to make multiple choice questions that really cause you to think for a long time. You're used to multiple choice questions in grades 9 to 12 pre-calculus are usually fairly straightforward, in that it's like one step to get the answer. Whereas AP Calculus, multiple choice questions, sometimes you have to think a long time about them. So you see how we started off with log 2 of 6 minus 3? And we combined it to a single logarithm. Then it reduced. Then I could take the reduced one and rewrite it expanded. And I could even evaluate this. And if the multiple choice question was log 2 of 6 minus 3 is equal to, and they give you a bunch of options, and one of them was log 2 of 3 minus 2, they don't look alike at all, but if we type them into our calculator, log base 2 of 6 minus 3, and then I take log base 2 of 3 minus 2, notice that we get the exact same answer. All right, questions for practice for number 2, 5, 8, 11, and